Assalamualaikum and hi everyone. We are from group 3. Today we will be presenting about chemistry in the topic of 5.2, which is liquid. My name is Alif Hakimi bin Shaiful Izan and I will be the first presenter to present my topic. Let's start the presentation by discussing boiling point. What's the definition of boiling point? The definition of boiling point is the temperature at which the vapor pressure of liquid is equal to the external atmospheric pressure. Vapor pressure equal or greater to external atmospheric pressure. It is not necessarily 1 atmosphere depending on the surrounding. Next point is boiling process, which is the start process changes from liquid to gaseous occur at the surface and inner part of the liquid, where bubbles are observed. Bubbles of vapor rise to the surface and escape from the liquid's bulk. Temperature remains constant during the boiling process even heat is applied. Occurs at the specific temperature and pressure according to its surrounding. For the next presentation, I will be discussing about factors affecting boiling point. For the first point, which is atmospheric pressure, when atmospheric pressure decrease, heat needed to make vapor pressure equals to atmospheric pressure decrease. Same goes to the boiling point. For example, Mount Fuji, which has a height of 3,776 meters, have a boiling point at 87 Celsius, while Mount Everest, which has a height of 8,848 meters, have a boiling point at 71 Celsius. For the next point, which is intermolecular forces, if the strength increase, the boiling point also increase. This can be said because a substance with weak intermolecular forces can easily vaporize and the system requires less heat to achieve atmospheric pressure. Thus, it boils at a lower temperature. I will pass the presentation to the next presenter.
Nextly, I would like to present about normal boiling point. The normal boiling point is the temperature at which liquid boils when the external pressure is equals to 1 atm. For example, if you boil water at top of a high mountain, its boiling point will be lower than 100 Celsius. But if you are at sea level where the atmospheric pressure is approximately 1 atm, the boiling point is the same as its normal boiling point, which is 100 Celsius for water. That's why whenever cooking at high altitude, it takes too longer.
Next, we will continue with the next slide. Vapor pressure. Vapor pressure is the pressure exerted by a vapor in equilibrium with its liquid state. Liquid molecules at the surface escape into the gas phase. These gas particles create pressure above the liquid in a closed container. Vapor pressure increases with increasing temperature. As temperature increases, the amount of vapor generated by a liquid in a closed container increase. It means that vapor pressure is directly proportional with temperature. This occurs because as the liquid gains kinetic energy, the molecules can overcome the intermolecular forces of attraction that are prevalent in the liquid phase.
Alright, so lastly, I would like to talk about the relationship between intermolecular forces, vapor pressure, and boiling point. When the intermolecular forces in a liquid are strong, the molecules require more energy to escape. This lowers the vapor pressure. On the other hand, weak intermolecular forces make it easier for molecules to escape, so vapor pressure is higher. Boiling occurs when vapor pressure equals the external pressure. Since vapor pressure is inversely proportional to boiling point, a liquid with strong intermolecular forces has a low vapor pressure and therefore a high boiling point. In short, strong intermolecular forces means low vapor pressure and high boiling point, while weak intermolecular forces means high vapor pressure and low boiling point.
Now, we will continue with some of the tutorial questions in the Chem Snap. A certain amount of liquid M is placed in evacuated vessel at temperature K. sketched graph shows the variation of the vapor pressure of the liquid M with time until the system has achieved equilibrium. And this is how the graph will look because the vapor pressure of liquid M increases rapidly at the beginning as evaporation occurs, then gradually slows down and finally becomes constant when a dynamic equilibrium between evaporation and condensation is reached. At first, the vapor pressure is zero because the vessel is evacuated. As molecules evaporate, the vapor pressure increases rapidly. Over time, condensation also begins, so the rate of increase slows down. Eventually, a dynamic equilibrium is reached. At this stage, the vapor pressure becomes constant, called the equilibrium vapor pressure.
That's all from our group. Thank you.